So let's see what you get. The starting point is you have sewage outfall. And because of these sewage outfalls, you have a distribution of a pollutant in your estuary, which can be expressed by a distribution of BOD, the biological oxygen demand. Okay, you can see here the distributions in milligrams per liter. Okay, and you get a higher pollution level in Hopewell compared to Richmond, and you get the peak values near the discharge. Okay, this is just a measure of the nutrient concentrations that you have. And the concentrations decrease away from the discharge, and similar to the method using freshwater fractions and saltwater fractions. Okay, so this is the starting point. The next is the predicted consequence in terms of dissolved oxygen deficit. So for each outfall, you can predict the dissolved oxygen deficit, and you can do that for each outfall individually. Okay, so for example, the green curve predicts that you get a peak dissolved oxygen deficit at about 15 kilometers downstream from the Richmond outfall. And this takes into account for the delay that it takes for bacteria to consume, to convert the organic material. Okay? Similarly, for the Hopewell discharge, you get a maximum which is located further downstream. And downstream, I mean in the direction of the mean flow towards the ocean. So now comes the key message. You can actually add up both curves here from Richmond and Hopewell. You get a combined curve which predicts your region of the expected maximum of the dissolved oxygen deficit, which is here at around 40 kilometers, which is downstream from the Hopewell plot. So now on the right side, I show you observations of dissolved oxygen in milligrams per liter. And you can see there are sufficiently high levels in most regions except for close to the 40-kilometer location where the levels drop to critically low levels. And this low level is a consequence of having two sewage outfalls, whereby one influences the other. Okay? So it's the combined effect of two sewage outfalls which actually create critically low dissolved oxygen concentration in a section of this estuaries in the James River. Okay, and there's quite a bit you can learn from this example.